This next module is a module on common stock valuation, where it's similar to preferred equity valuation, preferred stock valuation, except the dividends are not going to be fixed. Dividends could be all over the place, okay? And let's see how we can deal with those kinds of situations. We'll simplify it a little bit and assume that while they may not be the same dividend every year, they may be different at different points in time based on differences in growth rates at different points in time. Okay, so let's start with a simple case. This is a problem from your chapter 7. What is the fair value or intrinsic value of a share of common stock that has an expected dividend of $2 next year and all subsequent dividends grow at 5% per annum? Okay, your required rate of return is 12%. Okay, so first off, let's make sure we understand what's going on. What does this mean? In terms of a timeline, what this means is that, let's say this is time 0. At time 1, your dividend is going to be $2. Time 2, or in year 2, in this case, the dividend is growing at 5%. So this second dividend will be 2 times 1.05. Okay, so that's going to be growing at a 5% rate. So that's 2 times 1.05. So that's about, what is it, $2.10. Okay, so that is your next dividend in year 2. In year 3, this grows even more. This 2.10 is now becomes 2.10 times another 1.05 because it continues to grow at 5% here, 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 and so on. So the next dividend in year 3 becomes equal to, or is equal to, 2.21 roughly, right? When you take this times the 1.05, you get 2.21. The fourth dividend will be 2.21 grossed up by another 5%, and so on. Okay, that's what the stream of dividends looks like. The required rate of return here is 12%. Required rate of return is nothing but your discount rate. That's your opportunity cost. It's required in the sense that your other opportunities, in this case, that number suggests that your other opportunities are earning you about 12%. So that's your opportunity cost, and so you require that rate of return on this investment. So it's just different names for the discount rate. Again, I'm trying to give you all the possible names for discount rate that you might encounter. Okay, that's 12%. So if that's 12%, this is a stream of dividends that's growing. What is the value of the stock today, or what we call the intrinsic or the fair value of this asset? Happens to be called common equity. Okay, as you can see, this is let's think about what is this. This is not an annuity because it's not fixed, it continues forever. Is it a perpetuity? Sort of a perpetuity, but it's not quite a standard perpetuity because the amounts are changing every year. However, what is not changing is the growth rate is constant. So it is what we call a growing perpetuity, right? So the present value of a growing perpetuity is what you are trying to calculate. Present value of the growing perpetuity is simply the first payment receipt, in this case dividend. That's the 2 over R minus G. R is 12%. That's your required rate of return, your discount rate. G is 5%. G is your growth rate. So R minus G. Do this first and then do the division. So that's 2 over 0.07, right? So this is, again, the main thing here is to recognize that this is a growing perpetuity, and so the present value is simply the present value of a growing perpetuity, which then translates to $28 and about 57 cents, which is the intrinsic value of this perpetuity. Okay, So that's how you would calculate the intrinsic value of this common stock. Okay, let's put this in Excel, and I'm going to add a little complication to this particular problem. Okay, so what I have here in Excel is this part of Excel is still still have the same problem as before. What is the fair value or intrinsic value? And what I have here is your expected dividend, the growth rate of the dividend, which is 5%, the discount rate. So if you were to actually map out the actual dividends, the first dividend was $2. The next dividend, which as you can see from this formula here, up here, is this first dividend C14 times 1 plus C10, which is the 5%. So it's taking this value, growing it by 5%. Okay? Then the next value here is simply again taking the previous value and growing that by 5%, and so on. Okay? Now the intrinsic value, the fair value here at time 0, at year 0, okay, is, as we've seen, this is a growing perpetuity. We already calculated it, but in Excel you do equals, what would that be? The $2 dividend divided by, in brackets now, R, which is the 12%, minus G, which is the 5%, right? Okay, so you do that and you get the same $28.57. Okay, so the same thing in Excel. I just wrote out these numbers to show you what it looks like and to point out that this is a perpetuity, so that's why you see the dots here. Okay, so it continues for a long time. Okay, now let's, as I said, I'm going to modify this problem a little bit. So suppose we modify the case above. So the next dividend is still $2 as it was above. So it's still going to be $2 is your first dividend. Okay, so the dividend in year 1 is still going to be $2. Okay, but what we're going to do is we're going to say that dividends are going to grow at 5% for 2 years after that, only for 2 years. So dividend in year 2 will be higher by 5%. So it'll be this dividend times 1 plus the 5% growth rate. And because I want to, and then the third dividend, because it's growing at 5% for 2 years, will be this dividend times another 1 plus the same 5%. But after that, dividends will all grow at 2%, not at 5%. So that's going to be times 1 plus 2%, not 5%. And then this is going to grow at 2% and so on. Okay, so from this point on, they're all growing at 2% in year 5, in year 6, and so on. Now we want to value this thing today, intrinsic value. What is that going to be is the question. Okay, the thing to remember here is, now unlike in the previous case, this is not a growing perpetuity starting right away. However, starting in year 4, it does become a growing perpetuity, because starting in year 4 and thereafter, it's going to grow at a constant rate of 2%, right? So we use that and we calculate the present value of a growing perpetuity, but now starting in year 4. So if you do that, you bring it back to year 3. So that's going to be using your present value for growing perpetuity formula, R minus G, where R is still 12%. Now the G is 2%. Okay, so you bring that back. So now you have 3 dividends, and then you have this value in year 3, which is the present value of all these dividends that come after year 3, and they're all growing at 2%, and you've captured that value here. So once you have the 2249, you can forget about all this, and then all you have to do is to present value this, and these 2 cash flows occurring in year 3, right? So if you do that, you have, if I take the $2 here, $2.10 from year 2, and the 2470, which is the sum of this and this in year 3, because now 2249 is in year 3, I have 3 cash flows to value, right? I can just use my NPV function, use this discount rate, and then value all these cash flows. So I get a present value of $21.04. Okay. So again, what have we done here? We have, what complicates this is there are 2 growth rates, initial growth rate of 5% and then a constant growth rate of 2%. And the thing is to remember to break up the problem so that you capture the constant growth perpetuity only from time 4, bring it back to 1 year before that, and then bring everything back to time 0. Okay. With that, we conclude this module on stock value.